It turns out after this long correspondence between myself and this artist, that is why the hotline bling. Cool. All right. I don't know enough about the feud to know if that's the side I should take or not, or say that I should be talking to. Anyway, here's 48 from yesterday. Remember, as long as I can see evidence, whether you got the answer or not, we're going to be able to make sense of it, but here's the honest truth of it. We're focusing on what in this... Did you guys hear something? Weird. All right, we're focusing on what in this chapter? Matrices. It's the plural of a matrix. What's a matrix? A table. Now, every time I'm good with that answer, I'm always going to say something different. Anybody remember what I say? I don't call them tables. They can be used to solve systems, and we're going to see that today. A rectangular array. Totally just from the other discussion, if I were going to get another degree that wasn't a master's, two things that I would pursue. And like if I could live forever, I would pursue everything eventually because I'm a really curious person in general. Physics. I think that a degree in physics, like true physics, hard physics, I think it's interesting. It's just super fascinating to me. Total nerd move here for a second, but I've forgotten a lot of math. Makes sense. I haven't done it in such a long time. About 2 or 3 times a year, I'll go on a kick where like 2 weeks straight, all I watch on my YouTube. Don't watch shorts, don't watch anything else. I watch open course stuff from MIT to see how much do I remember about these classes that I took 10 to 30 years ago.
Classes.
Yeah, but from different professors. Like,
Yeah.
I don't remember a ton about topology, which is a field of math that you guys probably don't know about, but that's okay. About once a year, I'll go through and I'll watch a bunch of topology lectures just to see how much I remember, because I'm a nerd, and that's a good thing. All right. I'm all over the place today. Matrices. Cool. Sweet. Now, this problem is awesome. And what we're going to look at today is just a review from geometry. If lines are parallel, one, from a pure geometry standpoint, you don't do that. You put this on them, right? That means they're parallel. How about from algebra? 2 lines are parallel if and only if they have the same slope. Love that you said same and not equal, because undefined does not equal undefined, but they are the same. Okay, now, as we look at it, I know that that's true. So if I look at this, and I just drew the vectors, here's vector V is what I've named it, and vector U. So these are vectors which we haven't talked about in here, but there's a little overlap from physics stuff. This is how we write a vector. It starts at the origin and it ends at the point 4,1. Here I am starting in the green one at the origin, and I'm ending at the point 4,1. This is the vector. Here's the other vector. Now, they say find me the area of this parallelogram. We're going to gloss over the algebra to make sure we can hit the matrix stuff fairly quick. If you guys want to like literally do the algebra, I'm comfortable to do so, but I want to at least talk conceptually about it. If I want to find the area of this right off the bat, anybody recall the area of a parallelogram? Think of a nice parallelogram with 90-degree angles. It's a rectangle, right? That is a parallelogram. Both sides are parallel. I'm fine with that. What's the area of a rectangle? Base times height. Okay, without anything else, go way out on a limb here. What do you think the area of this different rectangle, parallelogram, but what's that area? Base times height. So all we need to be able to do is identify the base and the height. Now, back to geometry stuff where this all connects back, and it's been a while. If these were lines and I gave you equations, could you find the distance between them? Or even if I gave you 2 physical lines in front of you and I gave you all a piece of paper with the lines spaced, could you find the distance between them if I gave you a ruler? Is it possible that we all get the exact same number when we measure the distance? Theoretically, yes. However, do you think it's likely? Like, maybe if you're thinking, no, we're going to round a little bit differently, like that's reasonable. There's a bigger issue at hand. If I want the distance between these 2 lines, how on earth do we talk about that distance? Is this it? Like, if I just take the distance of this, is this the distance between these 2 lines? Kind of, maybe, right? Not a whole lot of confidence. Somebody else measures like this. Is that a distance between the 2 lines? Who's right then? And do you guys see the issue with this? One person measures 5 inches, the next person measures 8 inches, and now there's an issue, right? Turns out neither of these guys are right. Because, fun play on words, what angle do you think we should form when we're measuring this distance, what would be the right angle to form? This is the correct angle to form. We take it perpendicular to those sides. That's how you would actually do it. This is an idea that you see in geometry. If it wasn't stressed when you did it then, here it is. It's stressed now. Distance between parallel lines has to be perpendicular to both of them. Now, with that little thing in mind, this whole problem is pretty much just a review in geometry and algebra 1 or 2. And it took me like 15 minutes to do this problem just because it's so involved. We're going to talk about the logic of the problem. If you want to see the solution, I'll hook you up. But I have much more meaningful stuff than can you do the algebra. So let's just walk through how would we actually do this if we were doing the algebra without the calculations. I don't care what side's the base here as long as we pick one. Doesn't matter to me. Rafa, do you want green or blue to be the base? Okay, if green is the base, could you find this distance here, the width of the base? That's not rhetorical. Talk with your neighbors. I'm going to ask you to find a couple things, or at least how you would do it. I want you to find the base, the length of the base, knowing that, what's this point? 4, 1. Okay, talk with your neighbors. Don't calculate it. How do we find that base, the length of it? The Pythagorean theorem would work perfectly here, right? I know that this distance is 4 down here. Again, you do not have to work it. We're just talking about it. That's a 1. 4 squared is 16 plus 1 squared is 17. So I now know, based on this, no pun intended, the base is root 17. Do you guys agree?
Wait, can you repeat why again?
Yep. Two ways you can think of it. Pythagorean theorem works all fine. If I were to drop straight down, that'd be a right angle. I know that this bottom part is 4 because that's the x. The vertical is y. Or you could also use the distance formula between 0, 0 and that. But it turns out if I say distance formula or Pythagorean theorem, they're the same thing, just interpreted differently. Okay. Distance formula or Pythagorean theorem gets us that. Now, if I know the base, that's half the battle. The only other thing that I need is the height. And this is where it gets a little bit more challenging. To find the height, we need to go from base to base, yeah? I cannot just count straight up. Can't do it. Because a moment ago, we just reviewed that old geometry idea. When you measure the distance between two parallel lines, like the top and the bottom here, where the base is, that has to be what angle? Has to be a right angle. Which means this is where the problem gets a little bit more blah. This has to be my height, where I would extend this line out so I could measure it. This is the height of it. Now, it feels weird when it's written like this, but if I draw it just off to the side, I think you'll agree with me. If this is my base, then this distance right here is how tall it is. That's what I'm seeing happen. It's the same thing, we're just tilted and it feels odd. Okay, now we kick into like super algebra mode. Could you find an equation? Could you find the slope of this base? Tell me the slope of the base really quick. From here to here, this green line, how many up and how many over? Everybody agree that this slope goes up 1 and over 4. That means the slope of that green line is up 1 over 4, 1/4. Everybody agree with that? Okay, again, up to you if you write this down. We're going to see that with matrices, this 15 or 20-minute problem is like 30 seconds, and it's awesome. Okay, I have the slope. Now, this perpendicular right here that I know is perpendicular to that green line, could you find the slope of that? And dig. Oh, go ahead, Clecia. That dashed line. What's the slope of this line now is what I'm looking for. Knowing 100% is perpendicular.
Wait, how do you find the slope for what's the 1/4 slope?
So I counted from 0, 0 to 4, 1. I go rise over run is slope. It's up 1 over 4, and that's just it. Or, if you'd rather, if I told you to find the slope between 0, 0.
And that's for that bottom line?
Yep, it's just for this. Yep, that has a slope of 1/4.
Okay.
If you have a slope, how do you find its perpendicular slope? What's that word? So that's the whoa, that is correct. But what's the math word? Reciprocal. Okay, so again, we're not going to do all the calculations. I know that the slope of this now perpendicular, that's going to become my height, winds up being -4. flip it and change the sign. -4. So that means, and I'm going to write this out just here, the slope of my perpendicular is -4. More so, I don't care where you draw your height from. The height of, and I'm going to go back to this parallelogram so we can make sense of it. If I measured the height here, is it the same as the height here? Because parallel lines are equidistant. That's what it means. It's the same distance. Okay, I don't care which point we use. The way I've drawn it, it passes through 4, 1, right? Could it pass through some super ugly number on this line and I could still use it? Is 4, 1 easier than the super ugly number? I think so. Okay, so I go through 4, 1. If I know a slope and I know a point, could we find the equation of that perpendicular line? If I know a point and a slope, I could use point slope. Now, just because I'm scratching everywhere and it's getting a little bit ugly here, I'm just going to erase these so it's really clear and I'll change color. The way that I'm working right now, as I said, I found this slope and I know that my height will be perpendicular and this is the perpendicular line right here. That's not a line. I mean, it is, but not the line. That's my perpendicular. I know that the slope of that yellow line is -4 because the opposite reciprocal, and I know that it passes through the point 4, 1 because I picked it. It could have passed through the point 0, 0. It could have passed through this point, whatever it is. Doesn't matter where you draw it. It's the same.
What does it have to be perpendicular?
Because it's perpendicular to the base. Because if I said measure the height of this one, Huggins, and you gave me that measurement, that's garbage. That's not how you measure the height, right?
Yeah.
Because the height, you would have to measure it perpendicularly. It's just how we do it.
Yeah.
Yep.
Okay.
To make sure that we're all on the same page. Now, I know a point and I find it. I could find the equation of that perpendicular. So all I'm going to write here without actually doing it, y perpendicular is going to be equal conceptually to the equation of perpendicular line. Okay. Now, beyond that, this problem keeps going. And there's a ton of algebra at work. Could you tell me the slope of this top part up here? It's also 1/4, right? Could you find a line, an equation of a line, if we extended this out just like we did here? It's this extension happening here. Could you find me the equation of this orange line that happens to be the other base of my parallelogram? Like, conceivably, I know it passes through this point up here, which I think is going to be, let's see, if this is 3, 6, I know I go up 1 and over 4. So this must be the point, what, 7, or sorry, yeah, is it 7, 7? Cool. I could get this point. Could we find the equation of that orange line? Okay, so right now, using the slope and stuff that we've found, I just find y of other base. And now I have an equation, 2 equations, in fact. The distance, my height, is between here and here, and I'm changing colors just so often. This is my actual height of my parallelogram. If you had these 2 equations, could you find where they intersect? And by that I mean, could you find this point of intersection if we had orange and yellow line? You could solve the system to find it, right? You could now find the distance from 4, 1 to up here to get your height. And now we have a height of our parallelogram, we have a base, and you just multiply them. Okay, I'm not going to dive into it. If you want to come talk about the algebra, I'm happy to chat about it, but we'll do it elsewhere. I'm trying to find where my work for this one is, because I did a lot. This is 9.1.3, right? And this is 48. So my work actually doesn't look that bad, but I did a lot of it in my head. This is what it looks like when I do it. And it's the same thing that I just spoke about. Pause. I find the slopes. I used a different base, but that's fine. I did the same thing. I found the equation of a perpendicular. I found the equation of a different line. And then I solved the system to see where they crossed. And then I just found the distance between them. And it's the same idea, just I cut out a lot of steps without showing it all. I find the height. Lost my train of thought. Found the height, found the base, and I find the area. Okay, so what I care about for you guys, one, that algebra, we talked about it a little bit. If you look at it and go, I don't understand any of that algebra, please come talk to me. We should look through this problem. But here's the part that I really need. In your notes from yesterday, where you started working 48, if you didn't get to the end, we're just going to cheat, for lack of a better word, because we're going to see a better way to do this. I just want to say, after all this, and you can just use ... to, I hate that yellow. You can use these ellipses to say, look, a bunch of work happened, we just didn't show it. And I'm going to tell you that the area is 21 square units. I'm just going to give it to you for free. That is the area of that parallelogram. 21. Is that what you got? After what?
I just use like the matrix use it.
Okay, cool. So you did 48B then, right? Okay.
What's the inverse?
I don't know that did anybody else do 48B yesterday? Okay.
Oh, yeah.
Okay. Where's the connection between this big, long 15-minute algebra exercise? How did you do B? What did B ask you to do?
Find the determinant.
So be more specific with your language. On 48B, I think they say do this. And it looks like it's what? 3, 6, and I don't know the order. 4, 1, 3, 6?
Yeah.
And the fact that it's vertical bars, what is this asking me for? The determinant. Where do these points come from? Or these numbers that make up my matrix? They're my ordered pairs, right? This is a matrix and a determinant of a matrix where I've just written it so that I have one column be the x's and one column be the y's, right? Like that's what's happening. I can see the ordered pairs. Okay, let's calculate this determinant really quick. 4 times 6, I think is 24. Then what?
Minus 3.
Minus 3.
That's the area.
Huh. Well, gosh, that's super fortunate, and they hooked it up because, is this C?
Yeah.
Man, maybe we're just backward and we put this in. What's this determinant? 3 minus 24 equals negative 21. Okay, the last one. Part D, this is the big statement that I want to make sure that we have. It turns out that we can spend 15 or 20 minutes doing this algebra, and that's fine, that algebra is valuable, there's uses for it. But remember, efficiency is like the goal in a lot of things. What's faster? Oh my gosh, we cut out literally all the slopes, everything else, and we now have a real meaning to a determinant other than just saying, oh, it's these things. Right off the bat, part D, if you want to add this into your notes where we defined, do we define the determinant and how to find it? We did, right, in the notesy version? Pretty sure. Okay. Determinant of a 2 by 2. We just said, here it is. You calculate it, right? Right off the bat, part D asks us to interpret the meaning of it, I think. Can somebody read me 48D? Okay, I would star this one or add it to your determinant entry. What's the connection between the parallelogram that's formed by those points or those vectors and the determinant of the matrix that's made up of those points?
They give you the area. Yeah, I don't know.
The determinant is exactly equal. I'm going to say the absolute value, but I don't want to make it look like the determinant of the determinant. The determinant is exactly equal to the area of parallelogram, and this is my shorthand, which I didn't have you. This is parallelogram.
Yeah, I was wondering what logogram is.
Yep, logram is parallel because this is parallel. I don't write it vertically because it looks like my 11, so I slant it. Okay, turns out the determinant is just the area of the parallelogram that's formed by the matrices that make up that matrix. That's a long way to say it's an area. Okay, now this has huge time-saving applications. You never learned about matrices before. With that said, we have that. I want us to think one little step further. A triangle, if I start with a parallelogram, how do you get to a triangle from it? If you cut it in half along a diagonal, you make 2 triangles, right? Do me a favor with the fact that we just hopefully made the connection, if you did the determinants, that it's the area. I want you guys as a group to do number 49 real quick. Cool. The way that I'm going to do it today is I'm going to give you guys a couple minutes, just like we have been, as a group, not individually. I want you guys to talk and work through 49, and then we'll sum it up together here in just a moment. The second that we look at this matrix and I say, hey, here's a matrix with all these points, all I've done is I've gone into the third dimension, if you will, if you want like a geographic representation of it. You guys don't work in 3 dimensions. I'm going to make a triangle. You guys can with your hands as well. Put a triangle on your page, like flat down on your surface. That's a 2-dimensional triangle, right? Move it up, all points up 1 unit. Like vertically, because now we're in the 3rd dimension. Did it change the shape of your triangle? just by moving it up 1 in the z direction, which is what we've really done, nothing changes. It's the same triangle, it's just shifted up in space. Okay, now when we get this, the determinant by hand, we don't do. I'm not going to make you guys do. However, if we look at this, what is the determinant of this? I'm going to call this matrix A. So I looked at an answer and I saw it. Matrix A is, you said the determinant is 27? Okay, and I need to look because I lost my sheet. So we calculate the determinant. Cool, it's 27. Determinant, so I'm on B right now, and I don't know why I'm calling that C. And I'll just leave this out. It's a calculator, right? The determinant equals 27. Okay, when you change the order, does it change it? And they give me a different matrix where all that's happened is it looks like rows have been moved around and stuff, right? Does it change the determinant? Did it? Uh-oh. There might be a negative somewhere in this part of this photocopy.
Oh, that's probably it.
The negative might be killing us. Let me double check.
Because I got both of them wrong. It's the 5 right here.
Read me matrix on part C, row by row. 3, negative 5,
and
1.
this 3. And that 3.
Negative 3, 4, 1. 4, negative 2, 1. So I'll just show you mine since we're up here. Gosh, this would not be an issue if we had textbooks, just to be clear. Okay, before you erase stuff, is this what your matrices look like? On B, negative 3, 4, 1, 3, negative 5, 1, 4, negative 2, 1.
That was
43.
You got 43?
Yeah.
I got 9 and 43 for B and C.
yeah. That's what I got originally.
calculator earlier.
Now that I put the negative 3, it's right.
It's 27?
Uh-huh.
Okay. You have a typo.
No, yeah.
Yep, and
This is the first.
you have a typo because I have a typo because the printer has a typo. I'm just going to shift blame. Never my fault. All right. It's 27. That was a joke. But really, nothing's ever my fault. On C, when you fix the signs and stuff, what is it? Negative 27. Okay, so I'm not going to write it because we see it. It's there. How are A, B, and C related? So is the area of the triangle 27? So love it. I want to make this connection as clear as possible. We wrote like 5 minutes ago the determinant of the previous one on number 48. It gave us the area of the what? Now, a triangle is nothing but half of a parallelogram. Here's the kind of parallelogram that we're dealing with. The determinant is the area of this whole region, all of this. That triangle is how much of it? Half of it. So check it out. On part delta, that's my determination of the determinant and its meaning. Cool. I'm going to tell you, last one, E, different set of 3 points. I'm not going to make you guys do this one. But if I want the area of the triangle, super easy. The triangle is determined by 1/2 times the determinant of this new matrix that we make. And I don't know what I'm undoing, but I'm just going to do it here. Okay, on D. So 1/2 the determinant equals area of triangle. Now, the ones, I like my second explanation more. Rather than thinking what it does, did you guys catch, you two were the ones who maybe weren't paying a ton of attention because you were doing other math stuff. Did you catch the ones, how we can make sense of it?
What? Yeah.
Like, we talked about the multiplying, right? But check this out. If you didn't catch it, or if you did, just do it again. Make a triangle with your hand. Like with your fingers. Just make a triangle. Now, every one of these triangles, if you put it down flat on your page, in 2 dimensions, there's an x and a y at each endpoint. Now, what's the next dimension? We have x and y, that's like flat land. If we add z, we add now up and down. Like not on the graph, but in like 3 dimensions. So take your hand now and move it up 1 unit. So put it flat and then move everything up, whatever 1 unit is in your mind. Is it the same triangle? With the triangle that's now sitting here, so careful, you're looking at you're trying to trace it in your brain, which I get it. Just physically look at your hand. Is there still a triangle in front of you? Could you find its area? Now put your hand back down. Is it the same triangle? The same shape, same size, just different space? Same area.
Would the area be different?
Nope, it's the exact same, which is a better reason for why those ones are there.
How is that possible? If there's like...
Take this circle. Could you find its area
Not that
theoretically?
You're wrong,
No, we're just gonna justify differently. This is a circle, right?
Uh-huh.
Now that I hold it, it's a very different circle, but it's same shape, same size.
I thought what you were saying is that, yeah, I must have.
You're
it.
trying to trace it up to make the tent,
Yeah.
which you could and find volume, but we're looking at area. Cool. All right. Love it. Easier than finding it by talking the algebra stuff? I think so. Cool. All right. I want you guys to do just a few problems for me. We're pretty much done with this chapter, I think. I'm okay to kind of gloss over it. There's some stuff that your yellow book goes into that's much more in the weeds as far as this field of math is concerned. What I think we should do tomorrow is check and see how this goes. So, for tonight, in the next few minutes, what I want you to work on is I'm going to let you use a note card and tomorrow, and we're going to work on it. Like, I'll give us a few minutes now. We got 15 minutes right now. If you need to do more problems finding the area and stuff, it will not hurt you. However, I think we should make a note card, and I'll help you make it right now in the next 15 minutes. I'm good with that. Let's make sure everything matrix related we have down so that when I ask you to multiply or add or find an inverse or a determinant, we can make use of that. Cool. So, I'm going to pause it.